Hi, and welcome to 1.5 Vector Components. Look at all this nice info you can read here. The one thing I'll call out is the wording of these questions. So this is number 1, and it's done for you. The way it's worded, they tell you the letter, that's the name of the vector. They tell you the magnitude of the vector. And all of these, instead of like north, south, east, west, they reference the x and y axis. So 30 degrees above the x-axis. First, you have to identify this is the x-axis, and we're going 30 degrees above the x-axis, as opposed to 30 degrees below the x-axis would look like this. That's 30 degrees below the x-axis. That's a different vector because it's in a different direction. And even 30 degrees to the right of the y-axis, well, here's the y-axis. 30 degrees to the right is this way, and you'd name that 30 degrees. 30 degrees to the left of the y-axis is like that. You get the idea. And then you could even have the negative y-axis and the negative x-axis. So let's do number 1, or rather number 2, because number 1 was done for us. So it says find the components of, they're naming the vector, b is equal to 100 units, 30 degrees left of the y-axis. If it helps, you can draw your x and y axes. Then draw your vector. We're going 30 degrees to the left of the y-axis. So this is the positive y-axis. We're going 30 degrees to the left. And our vector is called b. The magnitude is 100. And our job is to find the components. So you break them up into the vertical, going up, and part of that vector is going to the left. So we'll call this by, the y component of b, and bx, the x component of b. So let's solve. You have to pick one first. Don't try to do both at the same time. So let's focus on bx. And is it opposite, adjacent, or hypotenuse to this angle? Bx is actually opposite the 30 degrees. So opposite and hypotenuse, we're going to do sine. Now, normally when you're solving for the x-axis, 9 times out of 10, when you're solving for x, you use cosine. But since this angle is the one that's given, we got to use sine. If they had given you, this is 60 degrees, if they said 60 degrees above the negative y-axis, then our x component would look like that. And then we could do, that would be adjacent, and we could do business as usual, cosine. But the reason these are written like this is because we want to keep you on your toes, and the shortcut doesn't always work. So you have to make sure you know what you're doing. So you plug in the numbers, and you cross multiply, and you get bx is equal to 50 units. For by, that's this leg, and that leg is adjacent to the adjacent to the angle. So adjacent and hypotenuse, we're going to use cosine. Plug in our numbers, and by is equal to 86.6 units. All right. Technically, since it's going to the left in the negative x direction, bx should be negative 50 units. That's the better answer. By is pointing up in the positive y direction, so we could leave that as positive. That'll come into play if you do any adding by components. If you break two vectors down into their x and y components, add the x components together, add the y components together, and then find the resultant. But I'm getting ahead of myself. Number 3. Number 3 says C is equal to 100 units, 30 degrees below the negative x-axis. Okay, and then it says, are both components negative? Did the previous one say something like that? No, it says, remember to use a negative sign for the x component. Yeah, that's what we did. Okay, so let's draw our axes. Identify where the negative x-axis is. It's the horizontal one on the left, and we're going to go below the negative x-axis. 30 degrees below the negative x-axis looks like that. We will draw in our x and y components, so x. Now, how do you know when to stop drawing the x, right? Do you keep going forever? No, you only go until you meet like the head. You have to be looking at, you look over here. Where is the head? And you stop right where the head is so that you can come down and meet the head right there. That's how you draw these components. A lot of times people don't know when to stop making it, and they're making all these crazy triangles. Make sure that the vector that they give you is the hypotenuse in this scenario. You don't want to make a hypotenuse and then make a right angle. It gets crazy, some of the things people do. So we'll use C sub x over here and C sub y. And now it's business as usual because CX is adjacent to our angle. So, and we have adjacent and hypotenuse. So for the x component, we can use cosine. Plug in, and you get CX is equal to 100 times cosine 30, 86.6. CY is opposite 30 degrees, and we have opposite and hypotenuse, so we're going to use sine. Plug in your numbers, and you get CY is equal to 50. Now this might get a little repetitive, so instead of writing the trig identities every single time, there is a shortcut, but it only works if CX is adjacent and CY is opposite. We could derive a convenient equation for ourselves. So I'm going to erase everything, and instead of plugging in these numbers first, let's just plug in C and CX and derive an equation. The adjacent is CX, and the hypotenuse is C. So every single time we're cross-multiplying, and we're getting CX is equal to C times cosine theta. So C is just your vector. And you could do the same thing for Y. When CY is opposite the angle, you could do CY and C, cross multiply, and you get C sine theta. These two equations are in your reference table, but instead of C's, they write them as A's, and they're located on the back page. So all the way on page 6 of your reference table, right here. Those equations only work if AY is opposite and AX is adjacent to those angles. Otherwise, they don't work and it's like flipped. But they're there for you. So in the one we just did, you could use those formulas, but in the first one we did, the X component was opposite the angle and we had to use sine. So this equation for AX would not have worked for this version. So I'm hesitant to show that equation even because it doesn't always work, but it does get super repetitive when you're doing the same thing over and over, cross multiply. So instead you could just plug in your calculator 100 cosine 30 in your calculator, and then you could rip through these problems. But be careful that the X is adjacent to the angle and the Y is opposite of the angle. Otherwise, you can't use that shortcut. Okay, sorry about that tangent. Get it? Pun intended, tangent. Anyway, find the components of D equals 60 units, 40 degrees below the x-axis. So this is not the negative x-axis, but the positive x-axis. And we're going below the x-axis. So 40 degrees. We'll draw in our components, and I'll show you the wrong way to do it. So don't keep going and then try to make a right angle here, and then this is your hypotenuse. Like, that's crazy towns, okay? You're just basically saying, how much to the right is this going? So it's only going this much to the right. This one's only going this far to the right. That's the x component. And then it goes this far down exactly. So you have dx and dy. All right, so dx, luckily, is adjacent, and dy is opposite. So we can use our shortcuts. The dx shortcut looks like this. Dx is equal to d cosine theta, and dy is equal to d sine theta. And now it's easy to plug in dx is equal to 60 cosine 40, and you just plug that right into your calculator. And dy is equal to 60 sine 40. So as soon as I verify that I can use the shortcuts by making sure x is adjacent, then it's off to the races and I can start plugging stuff into my calculator. Dx is equal to 46 degrees when you round it, and dy is equal to 38.6. Oh, not degrees, units. Sorry, units. Those are the size, the magnitude of each component. Okay, number 7. Find the components of E equals 70 units, 50 degrees below the x-axis. So again, similar to the last one, here's the x-axis. We're going 50 degrees now below the x-axis. And we can label it, draw in the x component, draw in the y component. I want to use the shortcut, so I'm going to verify that EX is adjacent to the angle, and it is. So I'll write the equation, substitute, and you get EX is equal to 45 units. For the y component, we'll write the equation, substitute, and the y component of E is 53.6 units. Unity, that's fine, units. 6, find the components of F equals 80 units, 60 degrees below the negative x-axis. So this might be confusing. Draw your axes, identify where the negative x-axis is, so it's horizontal and it's on the left side, and we're going 60 degrees below that. So here's the negative x-axis, and we're going 60 degrees below the negative x-axis. Oh, and I just realized that I did not think about what was positive and negative. I did so on number 2. For number 3, 4, 5, and 6, I'll have to go back, I guess, and I'll do that at the end to make the things negative and positive. So we'll draw the x component of F, the y component of F, verify that Fx is adjacent to the angle, so we can use the shortcut, substitute, and solve. So Fx is equal to 40 units. For Fy is opposite of the angle, so we can use that shortcut, substitute in our values, and Fy is equal to 69.3 units. For number 7, it says find the components of G is equal to 90 units, 20 degrees to the right of the negative y-axis. So let's draw our axes. Identify where is the negative y-axis. The negative y-axis is right here, and we're going to go 20 degrees to the right of that y-axis. So this is the y-axis, and we're going to the right 20 degrees. Now, I'm going to give myself some space. This is way more than 20 degrees, but we'll draw it like that, okay? Then we'll label it, and we're going to draw in our x and y components. So here is the y component. Now watch this. This is the vertical component, isn't it? You would call this gy. Well, is that opposite or adjacent to the angle? Gy is now adjacent to the angle, whereas before the y component was opposite the angle. So now we're not going to be able to use a shortcut. We're going to have to write it out. The x component is horizontal. You could do gx. Gx is now opposite that angle. So since it's opposite, it's not adjacent like it was before, and we're not going to use cosine. So again, we cannot use that shortcut. So we're going to have to write out the, cosine thing. So for gx, we said gx was opposite, and we have the hypotenuse. So if we have opposite and hypotenuse, we're going to use sine. Then we'll substitute in, and this time I'm going to substitute in the letters. Opposite over the hypotenuse. And we can cross multiply, and I'm basically deriving another equation for this particular scenario where it's g sine. So if you really liked the plugging in 90 sine 20 degrees right away, you can totally do that. But I'll do it the old school way and just plug in what we know. So sine 20 degrees is equal to gx over 90, and then gx again. So you still do the same thing, 90 times sine 20, and you get 30.8 units. For gy is adjacent, and we'll use the hypotenuse. Adjacent and hypotenuse, we'll use cosine. Substitute in our values, and you get 84.6 units. All right, now I was really careful about writing units every time, but I neglected to look at the direction of these vectors. So I did so on number 2. For number 3, cx is pointing to the left, so that's negative. Cy is pointing down, so that's also negative. So we have to make these two things negative. Dx is pointing to the right, so that's positive. Dy is pointing down, so that's negative. It's going in the negative y direction. Ex is pointing to the right, so that's cool, it's positive. Ey, though, is pointing down, so we have to make that negative. Fx has the movies. No, I'm just kidding. Do they even have that slogan anymore? Fx is pointing to the left, so that's negative. And Fy is also pointing down, so that's also negative. And finally, we have G, trying to get my green pen, Gy is pointing down, so Gy is negative. Gx is pointing to the right, so Gx is positive. I hope you're feeling pretty positive today. Very nice positive outlook on life. All right, that's about it. Have a great day.